Hello and welcome to Physics with Amol sir. Today we start with chapter 2 Electrostatic Potential and Capacitance. I hope that before starting with this class you have revised the previous concepts. So make sure you go through the notes and you go through the textbook most importantly. It is very important that we are reading from the textbook so that we get a full idea about the concepts. So with that, let us begin. So first let us talk about potential energy. Consider this is our source charge. Okay, so there is some amount of charge, that is capital Q, let us say. So we have a positive charge of capital Q. This is going to have an electric field around it. I am sure you remember the formula also. So at a distance of r, the electric field due to this charge Q will be given by 1 upon 4 pi epsilon 0 Q upon r square. Correct? I hope you remember this. So there is an electric field that is around this source charge. This is our test charge, okay, small q. Small q is at a certain distance from this charge, correct? Let us say this point is q. From point q, we want to bring it to some point p, okay? So we are going to move this test charge from one point to the other point. If this charge is positive, correct, and our source charge is also positive, there is going to be a repulsion. There is going to be an electrostatic force that will be acting on our test charge. So, to bring it from one point to another, you will have to apply an external force. Is that correct? If the charge is here, okay, let us call that point as R for example. Let us call it R. It is at a point R. Okay. To bring from R to a point P. Okay. So, we have moved it by some distance. To do this, we have had to apply an external force because during this time, this source charge, it was applying a force on our test charge. Correct? Continuously, there was a force being applied of repulsion. So, we did some work to do this. And this work done, that will get stored as the potential energy in our test charge. Making sense? Whenever a charge is being moved in an electric field, okay, to move that charge, some work needs to be done. And when work is done on that charge, it gets stored as the potential energy in that charge. And this is the definition of potential energy of a charge. So, potential energy of a charge Q is defined as work done in moving that charge from infinity to that point in the electric field. Okay, we are going to take it as infinity because we assume that at infinity the potential energy is 0. Okay, so once again, potential energy of a charge Q will be defined as work done in moving the charge from infinity to that point in the electric field. Obviously, you will see that if it is moved closer, the potential energy would have increased. Correct? So it depends on how much distance is being moved for that charge. That will get stored as the potential energy. Potential energy of a charge will be denoted by the symbol capital U. Okay, I hope that is clear. And also, potential energy is obviously a scalar quantity. Okay, so we don't need any direction for it. It is only defined by the magnitude. Now, next concept is the concept of electrostatic potential. Now you will see that both the words, they are sounding very similar. First we said potential energy and now it is electrostatic potential. Now what is electrostatic potential? Very simple to understand. Once again, this is our source charge. Now instead of calling this as a test charge, this charge we are going to give a magnitude of 1. So this will be a unit positive charge. Okay. So we say that work done in moving unit positive charge from one point to the other is called as the electrostatic potential. Okay, once again. So what we say, what is electrostatic potential? Work done in moving unit positive charge or 1 coulomb of charge. Okay, so work done in moving a unit positive charge from one point to another in an electric field is called as the electrostatic potential. Once again, it is a scalar quantity, and potential energy and electrostatic potential, these are the concepts. Okay, potential energy, when you measure, the unit for potential energy will be joules because it is energy. correct? But electrostatic potential, correct? The unit for electrostatic potential will be volts. Okay, so we denote electrostatic potential by the symbol of capital V, and also it is measured in volts. A simple formula I will give you. Okay, you can also say that the electrostatic potential is nothing but potential energy per unit charge. Okay, let us. Okay, so U, as we said, denotes the potential energy, and V denotes the electrostatic potential. Okay, two different concepts, please remember. U is potential energy and V stands for electrostatic potential. Both are scalar quantities. Electrostatic potential is measured in the unit of volts and potential energy is measured in the unit of joule. Okay, and as I said, you can just give a simple formula to this. What is the formula? You can say that electrostatic potential V is equal to work done upon charge. Correct? And work done is nothing but the potential energy. So you can also say V is equal to U by Q. Okay? So electrostatic potential is work done in moving a unit positive charge. So work upon charge. Or electrostatic potential is potential energy divided by the charge. So U upon Q. Okay? Please remember these very, very carefully because these are the basis for this particular chapter. Now, one more thing. There is another usable formula. Why do I say the word usable? Because we cannot find electrostatic potential by using these formulae. It becomes a little bit difficult. So there is a simple formula for electrostatic potential. The formula is like this. V as a function of R. Okay, R denotes the distance from the source charge to the test charge. It is given by VR is equal to 1 by 4 pi epsilon naught capital Q by R. Remember this formula. What is capital Q? Capital Q can be our source charge. Okay, then at a distance of, let us say this is the point P, at a distance of R from Q, this is where our test charge of 1 coulomb is kept. So at this point P, the electrostatic potential is given by 1 upon 4 pi epsilon naught Q by R. Again, this formula is important to remember. Okay, the proof of this formula I have given in the notes and you can find it in the textbook. It is a very, very simple proof, so I am not going to derive it here. But remember this formula. VR is equal to 1 upon 4 pi epsilon naught Q by R. Next, now this graph gives you the variation of electrostatic potential and the electric field with the distance. So if you notice and if you remember that electric field, the formula for electric field is 1 upon 4 pi epsilon naught Q by R square, and the formula for electrostatic potential is 1 upon 4 pi epsilon naught Q by R. So you can see that electric field, it is going to vary proportional to 1 upon R square, but electrostatic potential will vary by 1 upon R. So this graph gives the variation. If R is equal to 1, you will see both the values are similar. We are talking about numerical similarity. Okay, otherwise concepts are different. But numerically, E and V both will be similar for R is equal to 1. But for less than that, the values are different. If R is less than 1, in that case, E is going to be higher than V. But for R greater than 1, we notice that E is smaller than V. Okay. Sometimes in the exam, this graph is also asked. So make sure that you are understanding this. So I hope the concepts were understood. Now I have two tasks for you. The first task, as I said, you are going to read from the textbook. Read till the topic that we have finished, that is electrostatic potential. And I want you to solve example number 2.1. You can see this on the screen. Okay, a very, very simple example. This can be a 1 mark or 2 mark question. Okay, and you are going to make the graph as well. Okay, so for today we will stop here. I want you to go through these topics. Okay, in the next class we are going to do some more derivations. Alright, thank you.